medium, right, which is beneficial or detrimental. Applying a value on top of that is the next step that you do at the end of the simulation. But the purpose of this work is to try and connect together on a per region basis. You want to be able to answer the questions, where do I, user, get my services from? And the other question, who gets services from that piece of land? So we really want to get the spatial connectivity piece in there, because then we can actually say something about who's liable for different services, who's dependent upon which things, who's going to lose in the event of change to a public good, et cetera, et cetera. Who might want to target for a PES strategy, all those kinds of things. What land should be kept in conservation if you're a government entity, et cetera, et cetera. So one question we answer, to where and whom the benefits from each region flow, per region. We can do this. Weighted. It's quite nice. Cool maps. Provision sheds. The other way around. I look at each user and I want to say, what is the source of my ecosystem service benefits? I get something from these wetlands over here, and I get something from this forest over there, and the rest of it doesn't provide me anything for this service. But then for a different service, maybe I get a little bit from there, a little bit from here, and so on and so forth. So for each service, each user has a different spatial distribution of its sources. Flow interruptions is your sinks and rival users. So the things that get in the way of the medium getting to me, for good or for ill. Right? That might be good, and it's a bad thing flowing, in which case I assign value to the sinks. Those are the things that provide the ecosystem service, regulating benefit. But I want to know who's up there blocking that stuff from getting to me. Who's protecting me? What landscapes are protecting me? And which rival users am I competing with? If you need to think about issues of water rights and whatnot, for example. And of course, because we have all these routes, we can overlay and we can get these flow density maps, which look pretty fancy, and show you where it's all moving. Right? This is like wildlife migration corridors. Right? So we want to look at which areas exhibit the greatest flow density, and then think about substitutability between those different paths.